My name's Andrew May. I'm the Cloud Solutions Lead at Leading Edge, and welcome to this Columbus AWS Meetup for Kubernetes in the Wild. I won't be, I'm just doing the introduction, but Peter will be talking about all his experiences using EKS in AWS. So a couple of announcements first. Upcoming next month, we've got the AWS Community Day. This was going to be an event held in Columbus, but because of the coronavirus, it's turned into a virtual event. Still going ahead on June the 11th. You can register at that website, or if you just search for Midwest Community Day, you should be able to find it. And then you sign up via Eventbrite. It's a $5 ticket for an all-day conference. We have a great keynote speaker in Randall Hunt from AWS, and then there's a whole bunch of speakers from different user groups around the Midwest who'll be talking. And like I said, it's a whole-day event. Lots of good stuff. I should be saying that because I'm one of the presenters. If you want to speak at a future meetup, we are always looking for people to present. I'm not sure when we're planning to have the next one. We might skip June because of the community day. But we're always looking for presenters, and they can be first-time presenters. If you have a particular idea, then one option is to contact Angelo and Lena via the meetup page, probably where you signed up for this, and send them a message with your idea, and they can get in touch with you. They're the organizers. I'm just someone who attends regularly. If you have any questions during the presentation, then send a message to the chat. If it's something that I can answer, then I'll try and get you an answer immediately. If not, we'll sort of hold them to the end, and then Peter can have a look at them so that he's not distracted during the presentation. And finally, a short bio for Peter. He's been with us at Leading Edge since 2017, and he's a senior solutions developer. So now I'm going to end this intro deck, and then he should be able to start his presentation, and I will mute myself.
All right, let's get this thing going. If you paid attention to the introduction, my name is Peter Mayer. I'm a senior solutions developer at Leading Edge. I have a little bit of a weird background. Started off with a history degree, but found out that working in the history factory isn't exactly the most lucrative of business opportunities. So I eventually decided to follow my other passion, which is programming, and was fortunate enough to, first of all, get an internship at public safety that eventually led me to Leading Edge, where I had the wonderful opportunity to work on a fairly cool application, which was a rewrite of a fairly boring application that the rewrite involved EKS services. And that's what I'm going to talk about. I'm going to talk about my experiences, some of the lessons I learned from it, and can also go over some of the other supporting infrastructure, try to focus on the AWS things as much as I can. All right, so let's get this started. I'm going to start off with a fairly basic introduction to Kubernetes and a little bit background on Kubernetes. This wonderful little chart here, which was shamelessly stolen from the Kubernetes.io website, which I highly recommend you check out. It has excellent documentation, very technical documents. It's just generally a very good source of information for everything Kubernetes, as you might expect from their official documentation. In this diagram on the left-hand side, you'll see the kind of old school traditional deployment. In this type of infrastructure deployment, everything is just on a single server, no boundaries between resources, difficult to scale. You can always add more servers, but I mean, you can always solve the problem by adding more servers to it, right? In the middle, we have the virtualized deployment, which is a little bit closer to the containerized one. It's multiple VMs on a single server. Each machine has its own operating system and dedicated resources. Definitely easier to manage and scale. If you need more applications, just add more VMs. Similarly, the containerized application or containerized deployment is kind of taking that to the next level. It's similar to VMs, but in this case, each one shares an operating system, but every container has its own file system, CPU, memory, and is completely decoupled from the machines it's running on. Well, besides the operating system, this allows for highly flexible deployment. However, something has to manage all these containers, and this is where Kubernetes comes in. Kubernetes, you may have gathered, is a container orchestration system. And the name Kubernetes is interesting. It actually is one of the few times I get to put the time I spent studying my history degree to use. Kubernetes is Greek for helmsman or steersman, etc., guide or leader. And I think it's a very appropriate name for this. It manages your containers for you, right? It does a lot of the work that you would have to do manually, or that your DevOps team would have to do manually. And managing containers by hand can be a little problematic. In my experience, it's pretty easy to set something up, get it running using Docker, but then what happens when it goes down? How do you handle auto scaling? How do you deal with rollouts and rollbacks? And Kubernetes just in general makes it easier. There's, of course, other solutions you can use for managing all these problems, but Kubernetes is one, and in my opinion, it's a cool one and it's a lot of fun. So take a quick look at how Kubernetes is organized. Again, I shamelessly stole this from Kubernetes.io. You'll see that as a recurring theme. Just again, a great source for all of this information. This chart you don't really need to worry about too much, luckily, since EKS will manage most of the setup for you. The important things you will have to set up are the Kubernetes nodes, which are your workers. I'll get more into that a little bit later, but most of this chart, out of sight, out of mind. Unless you want to set up your own cluster at home, which could be fun, or set up your own on-premises infrastructure, but that's a whole topic for a different presentation, I think. So Kubernetes there's a lot of resources in your Kubernetes cluster. These are your applications and some various supporting pieces of infrastructure. Basically, your applications in Kubernetes are a set of resources that when pieced together form a working deployment. The two most important resources, and probably the easiest ones to understand, are the nodes and the pods. The nodes are the machines that actually run your workloads. They could be EC2 instances, they could be your grandmother's PC. It's just a little bit flexible. Now there's also serverless options with Fargate, which is pretty cool. And a pod is, in that chart I showed earlier on, the pod is effectively the container. There can be multiple containers per pod, so it's not necessarily that simple, but it's easiest to remember it that way, in my opinion. Pods are managed by resources such as deployments, daemon sets, or jobs. Each of these are just kind of different ways to manage and deploy your pods. Typically, you also need some form of ingress if you want to actually access your applications running in Kubernetes. The simplest one is a node port, but the load balancer is probably the one you're going to use most commonly, especially with any cloud deployment of Kubernetes. There's also roles and service accounts. If you're familiar with IAM or any kind of role-based authentication, it's very similar to that. And in fact, it links fairly well with AWS IAM roles. There are also many more resource types, but again, kind of like a lot of the complexity in the inherent system of Kubernetes, you don't need to worry about most of them. Just to give you an overview of the different types of resources, however, it kind of reminds me of the 151 different types of Pokemon. You don't need to worry about most of them. Just remember the useful and the cool ones. The most useful ones I find are are completely unavoidable to use. Are the config mappings, which is basically a dictionary, key value pairs. They can be referenced in other resources. They're namespaces, which are logical groupings of resources. I think I mentioned the last slide, but most but not all resources are unique per namespace. Some are an exception, such as the nodes being your worker nodes that actually run everything. Secrets are similar to config mapping, so they're just encrypted. I mentioned the daemon sets. Daemon sets are a very useful tool to use. They run replicas of one replica of your pod on every worker node. They're very useful for things such as logging. Later in the presentation, I'll go over an implementation of that. Replica set is, it's kind of a simple deployment. It just creates X number of replicas of a given pod. Stateful set is kind of a fancy replica set. It's useful if you're deploying a stateful application, not surprisingly, but it's also useful if you need stable identifiers or specific ordering, deployment, and scaling. Other than that, jobs and cron jobs are a little bit simpler. Cron jobs are useful sometimes if you need scheduled tasks. Jobs just execute a pod. You'll definitely need ingresses at some point. It defines how your resources are able to interact with each other. And the roles and cluster roles are those user roles I mentioned earlier. A cluster, the only difference really being that cluster roles, cluster wide, and roles are defined for a namespace. Deployments are probably the most useful one of these. I think they're a little bit more flexible. They support things like scaling and give you a little more options in, say, a basic replica set or some of the other options. They're the ones we ended up using at our project, so you'll be hearing about them a little bit later. Here we have a very extremely simple deployment that should theoretically allow you access to an Nginx instance in Kubernetes. All those resources I looked over are defined in YAML files and pushed through the REST API, and it's abstracted behind command line tools such as kubectl or Helm. You're going to be hearing a lot more about kubectl throughout this presentation. And at the bottom here, we have some examples of those YAMLs. Again, I shamelessly stole it from Kubernetes.io. If you've ever looked at Cloudformation, there's a lot of similarities there. I mean, it is YAML after all. This is about as simple as it can possibly be. The important portions of it being the container. You can see the image is Nginx, and we're going to create 3 replicas of it. This particular deployment isn't really much different than a replica set, but there's a lot more fancy options you can use, and you can see there down there at the bottom, it'll be listening on port 80. And the node port is just going to expose port 30007 on every one of your worker nodes, and it'll give you access to your Nginx instance there. The selector is wrong, mind you, but I didn't update the examples I just stole from Kubernetes.io. It should say app::Nginx here. All right, so now that I've gone over Kubernetes a little bit, I want to talk about EKS. EKS is a managed Kubernetes service for AWS. And like a lot of other AWS resources, EKS takes care of much of the responsibility of management, keeps it updated and more secure. If you remember that diagram a few slides back, Amazon deals with most of that for you. Definitely makes your life easier. Additionally, it runs across multiple availability zones. It allows for easy provisioning of extra worker nodes to handle increased demand via auto-scaling groups. This was something we had to worry about since there were spikes in demand occasionally. It's really nice just to be able to scale up those worker nodes as you need it. I'm really interested in the serverless option with Fargate for similar problems, since I think that's even more scalable, but that was not available at the time, and I'm not sure it would have been perfect for our solution. Still pretty cool. There's also no need to worry about security or patches, although there is a small caveat with that statement. Sometimes in Kubernetes patch, you will have to restart your cluster. I know we had to do that towards the end of my tenure, and if you don't restart it yourself, they'll restart it for you, so you just kind of want to schedule that. So that's not too bad, honestly. I already mentioned the serverless option via Fargate. Honestly, everything is pretty easy to set up. If you run through the AWS console, you can create an EKS cluster, and then once you set up your authentication, you can deploy those 2 YAMLs you saw on the previous page using kubectl, and you can have a working Nginx instance in probably like 20 minutes or so. Unfortunately, it is a lot more difficult to master, but definitely easy to start. It's also a little problematic for home projects, which I think kind of makes the learning curve a little bit harsher. One of the biggest issues is pricing. Also, it's sometimes not the most accessible thing, but still a lot of fun to play with. But wait, there's more. Integrations with AWS allow for easier management security. I think I already said that. But, part of the more specific details are VPCs and security groups, as with other AWS resources, allow for isolation. Integration with AWS IAM authentication allows you to limit the access. You can assign your Kubernetes account to IAM roles, which allows you to, your Kubernetes service account to IAM roles to granularly control access to other resources. And also, there's a wide variety of AMIs available, which kind of gives you a lot of flexibility depending on what your needs are. We have relatively simple needs in terms of processing, but if you have some kind of compute-heavy workload you need to run, there's AMIs out there for that. If you need a GPU, there's options for that, unless you're using Fargate. The cluster can also be deployed very easily. It's almost hard to believe how easy it is to deploy. This right here kind of shows an example of a config mapping, which is that set of key value pairs. And this particular one shows how the AWS IAM roles will sync up with the Kubernetes roles. If you look at the map users section down there, you'll see the RNs in here for your users, and then they map to a role, to a group in Kubernetes. In this case, it's system masters, which basically gives it total control over anything, which you usually would want to limit it down. You can use these roles to assign like the DevOps role for certain users in Kubernetes and maps to certain users in AWS, or maybe a super user role that links certain users in AWS to users in Kubernetes. It's definitely a handy tool. It's not perfect, and sometimes it's a little bit manual. It's definitely something you want to play around with. And I mentioned creating a cluster, extremely easy. You just need to there's different kinds of YAML configurations. On the left, there is EKSCTL, which is an alternate tool that I haven't really had a chance to play around with much. It's extremely specialized for creating EKS clusters and managing them. At our time, we used AWS Cloudformation, which is kind of a little more standardized and allowed us to use the same basic templates for everything and the same command line tool for everything. But if I were to do this again and work with EKS in the future, I'd probably play around with EKSCTL. I find it a little strange that the tool is so specialized, but I'm sure there's good reasons for it. So if you get a chance, I would recommend you play around with a little bit too. As far as cost goes, it's not really that expensive, at least at an enterprise scale. It's 10 cents per hour per cluster, which amounts to around $75 a month, which that's pretty freaking cheap. I'm not going to pay for it for my home uses because I'm poor, but it goes. Worker nodes aren't free, and that's where a lot of your cost is going to come from, especially if you have more complicated workloads and need some kind of very compute-heavy EC2 instances. If your workloads are fairly static and you know that you're going to need X number of worker nodes at any given time, you can use reserved instances to further lower your costs. Fargate's a little more complicated, I guess just because of the serverless nature. You basically pay for every second your pods are running. And another option is AWS Outposts. If you have a lot of on-premises resources, you're kind of hesitant to just throw them away, you want to put them to good use, then you can use these to run your worker nodes through AWS Outposts. Again, $75 a month is extremely cheap if you ask me for all the benefits you get. So I'm going to go on to our specific problem at Wendy's. We had an older application that needed to be updated to provide real-time data to an in-house data warehouse. The data needed to be accessible to third-party vendors. These vendors are basically the guys who manage the data for franchises. The old system used SFTP servers, and every vendor was responsible for their own systems. So it was very decentralized, completely outside of our control. It was a nightmare from a maintenance perspective. We get calls to the help desk all the time that something wasn't working, and it turned out that there was a problem with their SFTP cluster, or they had a firewall problem, but it all got routed through us, and it became kind of a mess. So the goal is to take ownership of the data, to centralize the storage and distribution of the data, and we need to provide high scalability, largely because of the data didn't come in a consistent trickle. It usually came in like someone ordered a hamburger, a little bit of data would come in, right? But some files would be updated, and we'd have to push those. But at end of day, there'd always be a large push of files. There'd be somewhere around 200 files per site. There were somewhere around 6,000 sites. And some of those files would contain up to 200,000 rows of records. So the volume got to be pretty big, but it was usually in one burst. And then in the middle of the night, there'd be almost no data. So any kind of auto-scaling features were definitely appreciated for us. Not nearly as bad as, say, the problem with Amazon and Black Friday, but still, it was definitely a concern. High availability was also a concern, especially around EOD time, since these processes determine whether or not the restaurant could close or the employees could go home and everybody could get on with their lives. And if there was an issue closing, then we'd end up hearing about it. Also, there would be large volumes of data, as I mentioned, with hundreds of thousands of records. So why did we choose EKS? Because it was cool. This might sound a bit like a joke, but it was at least partially true. There was an initiative at Wendy's at the time to start using Kubernetes for different solutions, and I guess because of the way the timing worked out, we ended up being the guinea pigs. High availability was a must, so we didn't want to kind of spin up our own Kubernetes instance and hope for the best. Multiple availability zones and relatively high guarantees of uptime definitely was something we were looking forward to. And again, scalability, as I mentioned before. Also, there were other cloud services we were going to use or that we were using, and putting it in the cloud just made integration with those easier. Maintenance was also a concern. At the time, we had a DevOps team that was extremely hammered at Wendy's, and they were migrating a substantial number of old legacy applications into the cloud, and they were all usually a little bit, I don't want to say understaffed, but they were definitely busy, and they didn't really have the time to set up and manage a Kubernetes cluster and learn everything from scratch. So going with EKS was just a little bit into the user solution. It also integrated well with our CI/CD pipeline. We're already deploying things to the AWS cloud, so this wasn't that alien. The security benefits, of course, and future-proofing, since everybody was trying to move to Kubernetes by using this as kind of a flagship, or as I would say, guinea pig application. It just kind of set the standard for possible future Kubernetes applications. So I'm going to go over some of the components we identified that we would need to solve this problem. First off was the EKS cluster, of course. We need something to store the data. That does sound a little bit vague, but that's kind of how the requirements were initially. They did want an RDS. We went with an Aurora RDS, but the reasoning for that wasn't necessarily great, since there's a BI team that uses that data for various different processes, for various different reports and whatnot. But the actual consumers of the data, being the back of house vendors and the restaurants, they just need the files themselves, and their systems are designed to handle the processing of these files. So we're trying to stand up a huge RDS that only a small percentage, and the percentage it doesn't actually pay for it, was looking for. So we switched to S3 because it gave us exactly what we needed. It stored the files, they were easy to retrieve, and it removed a lot of processing. It sped everything up. And we also needed EC2 worker nodes, of course. Then there's also some weirdness with TLS authentication. There's a future slide that kind of goes over some of that. And of course, we need a CI/CD pipeline. It wouldn't do much good if we couldn't actually deploy this application. So we needed to ramp up our knowledge on a lot of new and unfamiliar tech in fairly short order, which was actually pretty exciting. It was definitely one of my favorite times at that client. If there's a reason why Leading Edge's motto is real fun geeks, after all, we enjoy doing ridiculous things. Then, of course, after the initial high of looking at this cool thing we get to build, kind of subsides, we realize that, oh God, we actually have to build it. Luckily, we had a lot of help in design, a lot of good people at the Leading Edge helped, and people at Wendy's. But implementation, we had to figure out most of that by ourselves, a little bit of a trial by fire type situation. Like I said, looking at the nice little beautiful flow charts, everything appeared simple, easy, but real life is rarely that simple. And especially working with a technology like EKS, it's somewhat surprising how fast it changed, especially a couple of years ago when we started designing all this out and working on it. The online documentation seemed to change almost daily. I was trying to onboard somebody to teach him about some of the new stuff, and the guide I had for setting up your AWS command line tool to authenticate with Kubernetes and EKS, when I looked at it this time, the guide was completely different than what I had documented previously. So it's a little bit of whiplash, but it's fun. And usually when when new changes are released, it's almost always for the better. And the DevOps team, of course, was very busy. So perhaps against our will, I don't want to say that, we did enjoy it, but we became something like DevOps ancillaries. And of course, I have to thank the Kubernetes native community, since I keep talking about Kubernetes.io. Their website is excellent, and everywhere out there. Whenever I asked a question, the answers were always easily found. There really weren't that many blockers, despite the fact that technology is new, and definitely that's one of the positives of working with AWS and Kubernetes. All right, so one of our weird little problems was TLS authentication. There's probably better solutions for that now, but the existing application, we had an existing application that issued unique certificates per device. So the idea was we already have this. We'll just leverage it because we needed to be able to identify that the data coming in was for a certain restaurant or the request for data coming in was for a specific vendor. So we used these certificates and ended up with kind of a kludgy solution, but it worked pretty well. We used to perform TLS authentication outside of the cluster in EC2 instances running Nginx that perform TLS auth termination and forwarded the request with a certificate. When the single sentence description gets that long, you know you probably over-designed it a little bit. So then once it reached the service, we will then provide additional validation against the database and ensure the certificate thumbprint matched the sender. There is definitely a better way for this. Kubernetes itself does offer TLS authentication. I think there were some issues with it out of the box that we weren't quite able to resolve. They kind of led us to use this off cluster solution, but I think one thing we could probably have looked into is maybe performing this extended validation in something like a sidecar container instead of just running it all through this one application. But it's definitely something I would like to go back and kind of spend a little bit more time designing. Another issue we faced was storing the data in AWS. We had something of a disaster with our RDS, as I alluded to earlier. Each restaurant would send hundreds of files. Each file could have tens of thousands. I think the largest one had 200,000 rows. And the large uploads hit a bottleneck in the database. They're trying to flatten out that data, extract all this data, and then insert it even with bulk insert statements. This wasn't really working. We could probably have scaled up the database. We could have done SQL optimizations for months. Hopefully not that bad, but we just weren't getting the performance we needed. So we decided that we'd try to find a simpler solution. And like I said, Kubernetes itself had no problem. Kubernetes was handling our requests. Even during our load testing, everything was fine, but the bottleneck was at the database. So we decided, do we even need the data at this point? And we took a step back, reanalyzed the problem, and just kept it simple and went with S3, which saved us all a lot of time and definitely was a real life lesson in trying to keep it simple, stupid principle, and definitely going to bear that in mind in the future. We also looked at some other options, including DynamoDB, which I think would have solved our problems as well, but there's a little bit of resistance to document databases, a little bit unfamiliar. But we also had some issues with Ingress. Access to the cluster, of course, had to be very limited since there was employee information in some of these files that should not be shared, period. AWS, in theory, provided all the tools we needed, but we had some issues provisioning our own network load balancer and using it to link with our load balancer service in Kubernetes. We wanted to have this managed load balancer, perfectly secure, set up by itself, but it didn't really work because Kubernetes doesn't support using existing load balancers. I really wish that this would change, but as far as I know, it hasn't yet. Every load balancer service you create will magically create a load balancer, and it's a classic load balancer in AWS, which you should definitely change to a network load balancer, as classic load balancers are deprecated and rarely recommended. So rather than kind of fool around with it too much, we just kind of rolled with it. Network load balancers will work. Our deployment was unfortunately a little bit complicated by this because we're trying to go the infrastructure as code route. We just wanted to have all of our templates be nice and orderly to deploy what we need. But with the load balancer, we had to deploy it first, and then we had to use the EKSCTL command line tool to query some information from it, which would retrieve metadata that would give us information about what the load balancer is, so we could reference it in other Cloudformation scripts. It wasn't ideal. There might be better solutions to this now, but at the time it was a bit of a struggle, but eventually we got it working. And yeah, this is kind of a black box type problem. Uh, I like to understand as much of what's going on as possible, but with the load balancers, it kind of took a deeper dive through documentation, and there weren't as many customization options as I would have liked. There are also some ways around it. You can use a application load balancer, but it's a little bit more complicated, and I can go over that a little bit later. In fact, you have to use that with Fargate, which is fun. Here's an example of a network load balancer definition. I just wanted to include this so you remember to include this annotation. Because if you do not include this annotation, it will be a classic load balancer. So I want to go over some of the things that I think went well with our project. We had a fairly inexperienced team at first. We had a few years of it on the job, but we hadn't really worked with Kubernetes and had limited experience with AWS. But we did find that AWS made things pretty easy to work with, even for beginners like ourselves. We found Cloudformation templates really made defining all of our resources easy. At least, in my opinion, I think it gave me a better understanding of the infrastructure I was working with. I mean, I could see the infrastructure as puzzle pieces instead of just mysterious black boxes out there managed by somebody else. The auto scaling was intuitive and very easy to set up. I'm honestly not sure why I found that so impressive initially, but I guess it was just kind of cool to me to see that you can set up such a nice and dynamic and responsive auto scaling setup with very little work. S3 taught me that lesson about simplicity and keeping it simple. And starting with EKS was surprisingly easy because looking at all the complexities of Kubernetes and all of the different moving parts, it seems a little bit intimidating, but it's very easy to get started. The security went well. Our security team was pretty happy with us. IAM roles and IAM Authenticator allowed access to be very granular, and so our security team had to focus less on putting out our fires and more on putting out other fires, which feels good. And I keep mentioning kubectl because kubectl is definitely your friend. I don't think it's intuitive as some other parts. It takes a little bit of practice to learn, but it's definitely one of the fundamentals to working with Kubernetes. And no matter how your Kubernetes deployment works, no matter where it lives, I strongly recommend you spend time to master that command line tool. And this is kind of a case in point, which is troubleshooting your EKS cluster. In the beginning, we did not have very many tools at our disposal, which I'm not sure if that's entirely fair. We had the tools, we just didn't really use them. We were kind of learning along the way. We had a good deal of logging in our application, but we didn't have anything set up to easily access the logs. And kubectl is your friend now. But the kubectl get logs command, which is probably the simplest way to obtain logs, is a little bit limited, and it doesn't provide a solution to get aggregated logs, at least not just kubectl get logs. There is actually a kubectl get logs with certain arguments that can look for certain selectors on your pods and can provide something like aggregated logs, but we weren't quite advanced enough to figure out some of these cooler tricks at the time. Also, there was something of an issue in that the logging solution wasn't prioritized. The priority was to get data flowing, to get this application out there so that we could start testing it and start giving some of the vendors access to it, to start testing it on their side so they can integrate it with their systems. And it definitely would have saved some time in the long run if we had tackled the logging problem a little bit earlier. Another good kubectl command that ended up saving us a lot of time was this kubectl -it, which lets you open a shell inside of a pod from which you can do whatever you want. Again, your mileage on that one may vary, but for me at least, I think it's a really valuable tool for kind of exploring, kind of poking around, getting more of a deeper understanding of what's on your pod, and you can do some fun troubleshooting in dev that you probably don't want to do in production. So here's an example set of kubectl commands. There are quite a few commands out there, and the Kubernetes.io website has a very good cheat sheet for it. Some of the commands that you'll use are kubectl config view. This one, you don't necessarily need it if you just have a single cluster and you're managing your credentials and everything correctly, but it just will output your kubeconfig file, which is the file that allows you to authenticate with the cluster and has all of the authentication parameters in it. Sometimes it can get mixed up if you have some kind of crazy setup, but usually not too big of a concern. kubectl apply is kind of one of the bread and butter commands. It will create a resource as is defined in one of those YAML files you saw earlier. Another one is git services. There's a lot of these git commands you'll see. They just list whatever type of resources. The next one actually, it shouldn't say namespace there because nodes are not limited by namespace. That namespace command should actually be either above it or below it. But kubectl get nodes will list all your worker nodes. kubectl get pods will list all of your pods. There's a wide option, which will just make everything clear. It's a really robust command line tool. If you check out the documentation, there's a lot of different options for fancy outputs. And if you need to change a specific thing just for troubleshooting, the patch command can provide that for you, so you don't need to upload an entire new YAML file. It's a little bit more specialized, and I didn't end up using it too much, but it's nice to know it's an option. And the edit one's another interesting one that I actually never used myself, but I included it here because I kind of want to try it. It opens an editor and just kind of lets you edit resources on the fly, which sounds kind of fun. But we mostly worked with YAML files. We wanted to keep it as close as we could to our CI/CD pipelines. And logs, of course, is important. There's a lot of different switches you can supply to that will extend that command and make it a lot more useful than just the basic git logs for this pod. And I already went over the exit one. So now I'm going to go on to our eventual logging solution, which ended the headaches we were having with our crappy ad hoc logging. Running multiple shell windows to tail the logs of multiple pods simultaneously is a terrible solution. So we're looking for something like an elk stack, which is a very common logging solution implementing Elasticsearch, Logstash, and Kibana. Elasticsearch being an open source search and analytics engine, Logstash being a data source processing pipeline for collecting, posting, and storing logs, and Kibana being a data visualization tool. But we went with ESK, which is a very close cousin that's pretty common in the Kubernetes world. It replaces the Logstash component with Fluentd. It performs the same function as Logstash. Fluentd itself is run as a daemon set, which is that resource that runs one pod on every node, and it aggregates the logs from all your worker nodes and sends them to Elasticsearch. It's actually really cool. You can customize it so it can pull logs from different applications, and even pull things like audit logs, and definitely a very powerful tool that made our life substantially easier once we had it in place. And implementing is also pretty easy. There's just more YAML files. If you don't like YAML, you're going to have some trouble with some of this. But we just had to make a few more changes to our deployment scripts, and the SK stack is up and running. Of course, there was a little bit of troubleshooting and adjustments here and there, but that's pretty much always going to be the case. I love infrastructure in Scout, if you haven't figured it out. So on the other end of the ESK stack was Kibana, which is just a perfect troubleshooting tool for distributed applications. If you have a bunch of pods running, it's just so nice to be able to query them all at once in a single centralized location, no fumbling around in the dark, just run a simple query. It's really beautiful. And not only is the process itself beautiful, but the data visualization aspect is also fairly beautiful. Unfortunately, we only really got everything, the logging aspect, working towards the end of our tenure, so we only really scratched the surface. We didn't get to dig in as much as we'd like to creating some fancier dashboards and some more advanced visualization tools, but definitely out there. As Kibana's website itself says, a picture is worth 1,000 log lines, and I 100% agree with that. And it's probably not required for small scale applications, but the larger the scale of your application is, the more complex it is, the more pods you have, the more moving pieces. I would strongly recommend you look at something like ESK. And it's also open source, so gives you those feel-good vibes. I'm going to briefly go over the deployment now. Wendy's was largely a Microsoft shop. It's a little bit more complex than that. There's Java chunks and Microsoft chunks, but also some little Python enclaves too. But our little side was a Microsoft shop, and we had Azure DevOps servers, and well, they were TFS servers that were recently upgraded to Azure DevOps servers. But this deployment had to go through a GitLab pipeline, which was the preferred deployment server for the DevOps team. We came from kind of a background with the old-fashioned TFS style deployment, create push button deployment, builds and deployments through the TFS UI. And this deployment was a little bit more complex, and I really had never deployed anything close to this complex. And we didn't really have anyone on the team that had a ton of experience with that, but I mean, complexity makes things fun, right? Learning new things or challenges overcome, etc. But I mean, if we did the same thing every day, it'd be pretty boring. So, and like there were also existing solutions for cloud deployments from the DevOps team. It made our lives a little bit easier. They didn't really have an application being deployed that was quite like this one, but definitely we had some guidelines to go on, and it wasn't that bad. Basically, our requirements were to deploy everything to AWS, deploy all the resource definitions to Kubernetes, manage any schema updates to our database, and also package and publish the services application. So what did we need? We needed a GitLab pipeline. It's not that much different than the Azure pipelines file. I just kind of included this because I'm working on projects with more Azure DevOps pipelines now, and I really prefer the GitLab pipeline. I think it's a little bit more mature and easier to work with. It's kind of an aside. Also, we needed Cloudformation templates, of course. We used Bodo 3, which is the Python SDK upon which the AWS CLI is actually built. We also needed a Kubernetes resource deployment. So there's also a Kubernetes Python CLI tool. It's not nearly as well fleshed out as Bodo 3, which is incredibly mature and very well documented, but it's still pretty good. It's powerful. It gives you everything you need. There are a few little custom functions we'd have to write here and there, but all in all, it wasn't too bad. We also had to update our database. We ended up choosing Flyway tool. Choosing the Flyway tool, it's another one of those command line tools that I strongly recommend. It's very simple to use, has incredible documentation. It's open source. It's nice and easy. The order of operations is definitely one of the gotchas in this deployment. It's a little bit complex, and if things aren't deployed in exactly the right order, it's not necessarily going to work, which we had spent a little bit of time making sure that everything was wired up correctly, and not only wired up correctly, but was wired up in the correct order. One example is this is that we had to wait for the load balancer in order to be created in order to retrieve information about it that our EC2 instances running Nginx would need in order to forward the requests and actually get them into the Kubernetes cluster. So just a couple extra little extra commands we needed to add into our script that I would have preferred not to, but wasn't really much way around them at the time. So this is a little overview of what the deployment looked like. It's from memory, so I'm sure it's missing some details and might not be entirely accurate, but the first step was to create or update the cluster via Cloudformation. This step ultimately was removed and moved into a separate DevOps stack, which I think was a good decision since you don't really want to be constantly tearing down and updating your EKS cluster. Similarly, the database was ultimately moved out into a different stack. And then we would run the DB migrations through Flyway, create or update the worker nodes via CloudFormations. And then there's also some miscellaneous supporting resources that might need to be updated, such as the S3 stack or S3 bucket I mentioned earlier. And then we had to, after creation, assuming this was new or update or whatever, we had to retrieve the information from the EKS cluster and build a kubeconfig for authentication because none of our runners didn't have that information in them. It might have been nice to make some more specialized runners, but we had to pull that information on the fly. Then we had to create the deployment and load balancer, then retrieve the load balancer information and create that final TLS auth stack. And then finally, we create the logging stack. also via Cloudformation. And by the end of this, in theory at least, we would have a fully operational stack, which is the profit stack that we all need so much. So it's done, right? So after toiling away for the better part of the year, everything was ready to go, so time to ship it. But as things go, it's never going to actually work out that smoothly. So there was a code freeze, not caused by us, thankfully, I swear. And that led eventually cascading into other delays. We had some difficulty testing at scale, which basically there was a paid tool for load testing that we were supposed to be able to use, but we ended up not being able to use it because of how the resources were provisioned and how the budget was allocated. So we had to roll up our own solution with JMeter to kind of, again, AWS actually made that easier too, since we could spin up resources to do our own load testing without paying someone else to do it. But it's fun. Luckily, though, I think our designs and the technologies themselves inherently allow for future proofing. Since we had scalability in place, when it deployed to 6,000 restaurants, we found out that we needed to scale up the number of worker nodes. The option is there. All you'd have to do for the vast majority of changes would be make small modifications to our templates, either the Kubernetes resources or the AWS Cloudformation scripts. And again, infrastructure is go to your friend. In the end, we left before it was completely rolled out, which kind of bothers me a little bit, but I do think we left it in a good place. And last time I checked, everything was still working well. So I think we made a pretty good project, largely thanks to the technologies we were working with. There were, of course, challenges in working with EKS. As I mentioned before, it changed a little bit rapidly. I think it's stabilizing, though. Like I said, when we first started, it seemed like there'd be an update almost every day in some way to some aspect of our stack, but it seems like everything's a little more solidified now. And there's a lot of resources to understand, but again, it's as long as you kind of stay focused on the ones that you really need to work on from a developer perspective, it's not as daunting. There's a lot of black boxes, but the more you research, the more you work with it, some of those black boxes are kind of filled in and become a little more clear. There's always going to be a lot of moving pieces, and honestly, it could have been a lot worse I've heard of substantially more complicated microservice projects. We kind of make this look easy. And we ended up taking responsibility for almost the entire stack since we were the guys who were available and at the time, and infrastructure as code enabled that, and we had a really good DevOps team and security team that are willing to work with us and give us everything we need. The deployment was certainly a little bit challenging, but yeah, I definitely enjoyed it. I kind of like writing those complex scripts. And just push button deployments really are fun. Just when you see everything work, it's very rewarding. Also, because of all the new technology and some unfamiliar stuff we are working with, in the last few months, transferring knowledge was definitely a little bit of a challenge, but it's always going to be. Just make sure you document everything as best you can. The CLI tools, they're pretty powerful, and like I said, I pretty much love all of the ones I've worked with, but it can be a bit challenging integrating everything into a single pipeline, and not only that, but making sure everything you need is actually available in your runners, etc. It's also necessary to work very closely with the different teams. Like I said, we were lucky. We were able to get the permissions and information we needed usually fairly easily without too much delay. But if something new came up and there was a delay in getting permissions, a small issue might become a large issue that might take weeks to resolve. Just something to keep in mind. But that's more general. It's not really specific to chaos. So over what AWS technologies were used in this project. Of course, we use EC2 for our worker nodes, and it was more than one instance for TLS auth termination. It was actually an auto-scaling group. We also had S3 to store our data. We had an Aurora database originally to store process data, but eventually just to store various configurations and auth tables. Outfit Process 3 for our pre-DNSs. We had network load balancers for routing the requests to the TLS auth stack, and network load balancers that were created by Kubernetes for routing to the actual pods. And we also had AWS Secrets Manager, not surprisingly, for secrets. And I'm guessing you probably knew this one already. We definitely use EKS. There are some different options we could have used here. We could have used DynamoDB instead of S3 and probably could have replaced the RDS component as well. We could have also used an ALB instead of our network load balancers. We probably could have used Fargate for our EC2 instances, but I believe that I'm not exactly sure what update that was introduced, but I don't think that option was available at the time. Other we just missed it when we were researching. So yeah, another tool that would have made our life substantially easier is Helm. And my current clients, we're using Helm and Rancher to manage our Kubernetes cluster. And honestly, Helm has just been a great help. It helps you manage your resources by logically grouping them into these things called charts, and it provides you a robust CLI tool for managing them. We kind of rolled up a lot of the stuff that Helm would have done ourselves, kind of an ad hoc solution when there's already something well established and reliable out there to do it. Helm is kind of a container orchestration system. The charts consist of all of your Kubernetes resources, and they provide other benefits as well, such as templating of variables. We had the same requirements in our application, but we decided let's just roll out our own solution for variable injection and templating, and it worked, but we reinvented the wheel, which is kind of stupid. It also supports chart dependencies, which are potentially very useful for more complex deployments. And also, it maintains a version history. This one I think is pretty big, especially when especially in the early stages or when you have a lot of changes going on around. It allows you to roll back your previous version of a chart fairly easily. We had kind of similar systems in place in that we could roll back to a previous version of our deployment, but that would roll back the entire infrastructure to the previous version of the deployment, which might be overkill depending on what the issue is we're trying to solve. We're also using Rancher right now, which is another tool for managing Kubernetes clusters, perfectly compatible with EKS. It features a very robust UI. It's actually fairly pretty to look at as far as any Kubernetes tools go, and gives you most of the tools that kubectl does in a graphical UI. It's fairly easy to use, but it wasn't really designed specifically for Kubernetes, so some of the nomenclature is a little bit confusing, and it doesn't necessarily help with long-term maintenance, updating, and deployment of infrastructure. It also costs money, but if you can afford it, go ahead. It's nice to have that UI, but of all the tools, I wouldn't really prioritize this one. I think having a fundamental understanding of working with kubectl and maybe integrating a tool like Helm will give you a lot more mileage than the UI such as Rancher. There's also a lot of other dashboard type applications you can deploy to your cluster that aren't going to be quite as powerful and as complete as Rancher, but they can kind of give you some of the same features for no cost instead of cost of licensing fees. I'm going to briefly talk now about some of the other AWS technologies we could have used. CloudTrail that's not entirely fair to say we didn't use that. The DevOps team did use CloudTrail. We just didn't really pay any attention to it ourselves as developers. I kind of want to go over it a little bit, but it creates a record of events in your account, and it delivers all of those to S3 for easy auditing. For EKS in particular, it logs create cluster, list cluster, and delete cluster events. In general, no one should be creating or deleting clusters, but it's good to know if any of those events happen, especially outside of the ICD pipeline. It doesn't, however, log any activity from kubectl commands. I don't know how it would, honestly, but this would be a really great feature to have, and it would be kind of a fun side project to research. It would be kind of nice if you could get all those audit logs into a single place. You can get the Kubernetes audit logs out when they can be pulled via FluentD and processed by the same EFK stack. It's just not going to be inherently integrated with the same CloudTrail stuff. So if I went back and do it again, I wouldn't mind exploring kind of merging these logs a little bit, especially since the IAM accounts are at least proxied to the accounts in Kubernetes. And another option that is actually sometimes required depending on how your cluster is structured, if you use Fargate for your worker nodes, you will need to use an ALB Ingress Controller. As I mentioned before, by default, it creates a classic load balancer, but this can and generally should always be overwritten to be an ELB. I hope that Kubernetes updates that to make the network load balancer the default at some point in the near future. But but this also can be superseded by an application load balancer. Still will create a new resource for every case load balancer, and it's required for use with Fargate. Application load balancers are a little bit different. I don't really need to worry too much about that. Theoretically, network load balancers are better at handling heavy loads, but it really depends on your specific application. In order for this to get working, there's something called an ALB Ingress Controller you need to deploy to your EKS cluster. I don't think I actually included details on that in this slide. I probably should have. But it's just another resource you can deploy. The setup is fairly easy. There is a very good documentation on AWS and AWS's website for this. Fargate is a serverless option that provides an alternative to running worker nodes instead of using EC2. It might make your management a little bit easier since you no longer need to manage your instances or EC2 instances or scaling. Of course, there's going to be some management you're going to have to do. Specifically, you need to create something called a Fargate profile. It defines a series of selectors that when matching a pod, it defines a series of selectors that pods will use to determine what type of what it's going to run, basically, what it's going to provision in order to run this. It's a pretty interesting model, and it does give you some interesting options since you can run different pods under different roles. And it's a little bit easier than with EC2. It doesn't support daemon sets. You're going to be limited to some things. You're not going to be able to use the same logging solution. It also doesn't provide pod level security isolation, which may or may not be a concern for you. Stateful applications also don't work very well, but there's a workaround such as using Esprit or Dynamo for pod data. So you lose a little bit of control in some areas, but in some ways it's easier to manage. You get a little bit of other options in others. So it's an interesting alternative that I definitely would like to work with more. AppMesh is something that I just recently learned about that I definitely would like to play around with. It's built on Envoy, which is an open source service proxy designed for cloud native applications. It's very microservice focused. It was built by Lyft. It gives end-to-end visibility, ensures high availability. It does this by creating a standardized proxy between services. Again, it's very useful for microservice architecture, and it allows direct communication between services. I don't know if direct is the right word since it's still proxied, but it allows for, for a common interface between services. It also integrates with CloudWatch and X-Ray for increased visibility. And it in some way simplifies that communication between resources, assuming AppMesh is set up for all of it. So some really brief use cases on it, kind of some cool stuff you can do. If you're deploying a new version of your service, it supports weighted routes, which it's like a limited deployment. So if you have V1 of a service, you can deploy that V1 to 75%, and you can deploy V2 to 25%. And that way you can just instead of exposing your entire user base to a new version of your service, you can expose a limited subset, and then you can just easily roll it back. And if you need to, or you can roll out the new version fully to everything. Another alternative would be you can keep your V1 and your V2 versions of the services out there. But if the old service is not reachable, if it fails some health checks, you can have if the new service fails some health checks, you can have it reroute back to the old one that's hopefully stable by that point. Also, microservices is kind of one of the things it was designed for. The single common interface for connections is handy, and it might simplify your needs for complex ingress and egress flows. Might not, but but facilitates slightly easier communication with non-EKS resources as well. And I think that's pretty much the end of everything here. My conclusions are EKS is just a very great tool for enterprise level solutions. It can be a little bit daunting to learn, but once you have the basics, I definitely think it's very, very rewarding to work with and fun. Amazon is also extremely committed to EKS being one of the platforms of the future. and they're all providing frequent updates and adding new features that are definitely for the better. This might actually be a benefit to some people, depending on your personality and your preferences for coding, but you'll end up using a lot of command line tools. They're all very well documented, those, so it's generally an enjoyable experience. Deployments also be complex, but I mean, deployments can always be a little bit complex. And troubleshooting can be difficult until you've kind of matured your application a little bit and you have everything in place. And finally, even if you're just working with EKS, the knowledge you gain working with Kubernetes will apply anywhere. The same tools, EKSCTL, Helm, they can be used on any Kubernetes cluster. It is not inherent to EKS, so definitely very useful knowledge to have. And that's the end. Thank you everybody for joining us, and happy sailing with Kubernetes at the helm.
So Peter, if you've got time, we do have a couple of questions.
I can do my best to answer them.
So the first one was, what EC2 instance type did you use for your nodes, and how did you decide that?
A good question. I don't actually remember the exact instance size we used. Where we ultimately decided it was a little bit by trial and error. I'm not sure if there's a perfect way to do this. We ended up just kind of going with the feelings of some more experienced developers and designers who've worked with AWS before and kind of knew approximately what we needed. And then we did some load testing to see if there were really any issues with performance. And we didn't really have an extremely scientific approach to choosing those sizes. But that's actually a good question that I'm curious to hear some other answers for us. And at the time, we really didn't have a great solution for determining exactly what size we needed, since this was a new service and we didn't know exactly what the load was going to be.
I know from experimentation I've done with EKS that the different EC2 instances allow a different number of pods per instance type. So if you use the very small instance types, you can only put a very small number of containers onto those. So it's kind of a balance of cost versus efficiency.
Yeah, I think we ended up with one of the large instances in production, but we didn't have a ton of pods or worker nodes at the end. Honestly, we knew that we might have to scale up, but by the time I left the project, we didn't really have the final full-scale solution done because of those delays I mentioned.
Okay, thanks. Another question we had was whether ECS was evaluated before using EKS or Kubernetes in general.
It was evaluated. We looked at a few different options, but one of the driving forces for Kubernetes in our application was we knew that other projects wanted to migrate into Kubernetes, and we knew that Kubernetes would be a viable solution for us. So we got kind of pushed into it as kind of the pilot for using Kubernetes.
Okay. There are a couple of other questions that I think have largely been answered by bits later in the slides about log aggregation and sort of ingress. Did you use anything? You used obviously the Fluentd for log aggregation. Did you use anything for sort of metric monitoring, like New Relic or Datadog?
No, we did not. There was discussions around that, but I believe the DevOps team was working on integrating New Relic, but that was not completed by the time I left, and it was a little bit outside the scope of what we were working on.
Okay. There was another question regarding volume provisioners in AWS EKS. So I'm not sure how much awareness you have of that. I know you can certainly use EBS volumes. I'm not sure what else the options are. Is that something you know more about?
No, we didn't really touch on that, unfortunately. like I said, I'm always learning more information about Kubernetes, and I'm glad to still be working on it right now. But there's a lot of different resources, especially when it is cloud-specific technology. So, unfortunately, I did not get to touch on that in my time.
Yeah, the question here, did you use multiple clusters and multiple services within a cluster, and any recommendations or best practices?
We did use multiple clusters. In general, I think it's best to use one cluster per environment. Um, there's depending if you're really scaling the truly astounding levels, you might want to consider multiple clusters, but it's extremely scalable. I remember I looked up the number of maximum number of pods you can have running at once in a single large scale EKS cluster, and it's very very large. So my recommendation would just be one cluster per environment.
Okay, well, I think that covers all the questions that we've had. So thank you for presenting. And like I said in the introduction, we've got the AWS Summit coming up on June the 11th. So I look forward to virtually seeing you you there. I believe the hope is that the conference will be in person the following year and in Columbus, as it was due to be this year. And as I said, we're also always looking for speakers for the AWS Meetup. So thank you, everyone, for attending. And we will try and send out via the Meetup a link to a video of the presentation.
Thank you everyone for coming. I definitely enjoyed having the opportunity to give this presentation.